Hello everyone, I am Jitesh. I am a faculty at the Mathematical and Physical Sciences Division in the School of Arts and Sciences at Ahmedabad University. And today I am going to tell you about the course Mathematical Modeling which will be taught in the upcoming semester in the winter of 2026. The course is titled Mathematical Modeling. Through this course, we will explore the power of models across various disciplines from biology, physics, economics, and engineering. Just to give you a brief insight, why mathematical modeling? So if we divide, our world into two sort of as shown here, like into real and a math world. Real world often contains problems which are often vague and difficult and complex to describe. But to solve these problems, we need definitive answers, clear solutions. And this is where the math world comes in, where we can define the problem in a more definitive manner. By defining the problem, we can describe using certain mathematical tools, using governing equations, and we can follow through by building very interesting and important and useful models, which gives us interesting solutions and tell us a definitive or something predictive about the problems that we are addressing. And of course, the model world is intricately connected with the real world through the analysis and the exploration and analysis of real data itself, which is often used for validation of the models. So basically, in a gist, real world problems are complex and interrelated. We can translate those into mathematical equations. We can predict, analyze, and optimize these models. And this is how scientists and engineers solve real challenges using mathematical modeling. So through this course, what you will learn is to formulate real world problems as mathematical models, propose and build mathematical models, analyze real data, test certain model assumptions, refine those models, generate testable predictions. And with this, we hope that you will also learn decision making using models. And we will be exploring various terrains from species population modeling to investment plans models and so on. So just to give you a brief insight, imagine this is a real data collected of a population growth over time. The real data may look, have various patterns. For example, this black curve goes up, this red curve slightly is saturating. To explain this phenomena, mathematical modeling can play a key insight as shown by this phase plot here, and which we use to come up with certain various kinds of models as represented by equations here. And interestingly, both of these equations can produce the patterns that are observed here. So in a nutshell, there is a lot of philosophy here, like which model is useful and which model is more realistic and more validated. Interestingly, these simple equations can lead to very complex dynamics, interesting complex dynamics, which we will of course look here. And then by building these foundations, we will move to certain applications in certain disciplines where our focus would be engineering, physics, economics, and biology. And for example, in engineering, we will be looking at, for example, traffic flow models using and where we build models from simple models where, for example, there is a following vehicle and a preceding vehicle, how the speed of this depends on the distance between them, the difference in speeds between them, and so on. And there is a lot of hierarchy, as you can see here, all the way from simple model based on constant time headway is the distance between the two vehicles, all the way to building more complex models where we can divide the entire road into discrete cells and do a lot of interesting analysis. We will move into the other domain, which is economics, and where we will also look at various aspects such as modeling long-run economic growth, endogenous growth models emphasizing human capital accumulation, how money, goods, services flow between household, firms, government, and looking at oligopoly model where firms choose production quantities and interact through market demand. And of course, we will also have biology as our key component, where we will look at various models all the way from competition between different species to modeling allele effects, and as well as evolutionary game theory, where we will describe interaction between populations where individual success depends on the strategies of others, and the applications are numerous, from animal behavior to the evolution of cooperation in societies of animals. So with that, what we want to do is to take a multidisciplinary approach where students from various disciplines learn together the modeling of various different disciplines, and also integrate and cross disciplinary boundaries. The course structure comprises of case studies from multiple disciplines, interactive tutorials in Python and Excel, project work, weekly assignments, quizzes, and there is also fieldwork opportunities and learning simulations. This is ideal for students from various backgrounds, as already emphasized, from mathematics, computer science, physics, life science, economics, business analytics, and the prerequisite is introductory calculus or calculus-based mathematics in class 11th and 12th. So with that, join us next semester right here.